Good afternoon, everybody, and welcome to our very first MetalCon Live of the new year. Today, I am very excited and happy to be joined by Gary Edgar of PPG, who will be presenting architectural applications for liquid and powder coatings. This course is HSW approved, so please be sure that if you do need the AIA credits, you submit the information that will come at the very end of this webinar. I am so excited to also announce that coming up in February, we will have some additional MetalCon Live programming coming to you. The very first one is Powerful Strategies for Converting Asphalt Shingles to Metal Sales Leads. That'll be presented by Todd Miller of AIA Industries, and it was one of our most popular sessions at MetalCon 2023. I'm also excited to let you know we have another fantastic program lineup coming from the future leaders of MetalCon and the MCA. This very first one for that program will be on March 6th, and it is Employment in the Metal Industries, Maximizing Your Experience. Samuel Gray will be joining us from Metallic Products to present that session as well. I'm also, of course, incredibly happy to let you all know that MetalCon is coming to Atlanta, Georgia this year from October 30th through November 1st. So be ready for a fantastic Halloween edition of MetalCon 2024. We look forward to seeing you all there. Be sure that you check out the link on the webpage so that way we can get you pre-registered for MetalCon. And last but not least, again, to receive that credit for today's course, please just submit the information at the very end of this webinar. It'll be a pop-up that comes up on your screen. If you have any further questions about accreditation or receiving that credit, you can always email me directly at kaylin@metalcon.com. Lastly, if you have any technical issues or any questions, submit that into the chat box on the screen, and we will make sure that if it is a question for Gary, that question is asked. And if it's just a general question regarding MetalCon, I can help you in the chat as well. Without further ado, I'm going to hand this over to Gary to take us into the world of liquid and powder coatings. Gary?
Oh, fantastic. Thank you. It's great to be here. Let me move my screen over. Okay, hopefully everybody can see my screen. MetalCon navigating factory applied liquid coatings. Dan, can you see that?
We do see your screen, Gary. We're all set.
All right, perfect. Thank you. So let me pull my mouse over. So good afternoon, everybody, or good morning. It's great to be here. We're going to talk a little bit about factory applied coatings today. I am Gary Edgar, and I've been with PPG. I'm the specification manager for coil extrusion products, liquid and powder, and also we deal with our air dry products that give somewhat similar performance. So today we're going to talk about navigating the complexities of factory applied coatings. Actually, there's liquid powder, everybody's probably or may not be familiar with, and then there's coil and extrusion applications, and then there's also touch-ups. So we're going to learn a lot today. We're going to touch on many different things. Hopefully it doesn't confuse you, but if you do get confused or have questions, I mean, certainly you can reach out to me at PPG, and me and one of my colleagues will certainly help you. So we're going to talk a little bit about PPG. So it's a global company. We were founded in 1883, just celebrated actually 140 years, which is pretty phenomenal. We're headquartered in Pittsburgh, Pennsylvania. I'm actually in Springdale, Pennsylvania today. It's a great sunny day. It's about 75 degrees, light wind. And we have about 50,000 employees, and we have 70 facilities throughout the globe. So exciting stuff. So our portfolio, we're about $18 billion in business. We have performance coatings and industrial coatings. So PPG touches a lot of different surfaces throughout the world and throughout your surroundings today. So we're divided up in between performance coatings and industrial coatings. Industrial coatings are typically the coatings that are put on in a factory, and the performance coatings are typically air dry or chemically cured products that you see, like latex house paint, epoxies, urethanes for painting tanks and ships. So when we talk about the different markets that we hit, certainly, I mean, we have transportation, heavy duty, but today we're going to be talking about coil and extrusion coatings going across the top. We also do wood flooring, consumer products, kitchenware, right? Appliance. So, I mean, just thinking about this just a little bit, that big green tractor, that's something we coat. There's pots and pans, that cell phone, that computer you're probably using right now, that mouse you're holding, that desk chair that you're sitting in right now. It's pretty phenomenal. And again, more things. Again, we're going to talk about monumental buildings today, but there you go, power plants, desk chairs. We also paint Titleist golf balls. We're recognized as a leader in innovation, sustainability, and color. And so our R&D headquarters are in Allison Park, which is right down the street from Springdale, which is right down the street from, well, Pittsburgh. So we invested $47 million in 2022. We have, several thousand, 3,500 technical employees throughout the world, and we have, over 500 patents in the last 10 years. When we talk about sustainability, our goal is to be 40% of our total sales to be sustainable products in 2025. And actually, we're well on our way there. I think we've actually crossed that threshold. So we're going to be making new goals. So we're well on our way. When we talk about color, here's color of the year. This is actually color of the year for 2023. We have 5 business units that come up with these colors, the colors of the year. And we have color experts throughout the globe, throughout the world that actually work on this in 4 different regions. So Vining Ivy was our color of 2023. And look at this one. We got Limitless. It's going to be Limitless in 2024. And there's the color of the year. And I mean, again, we talk about the different products that we work with. So we have our pre-treatment, electrocoat, liquid coatings, and then powder coatings, which we're going to be talking about today, ultraviolet or electrobeam coatings, and coating services. Coating services actually goes and helps put in lines, right? So application lines for our customers that help them apply the material and ensures that the line works properly and the coatings are applied correctly. I'm going to play a quick video here about PPG.
Why do our 50,000 employees come to work every day? To help communities come together and grow in more inspiring spaces. To preserve the environment for future generations. To protect the world around us from the elements and everything else. At PPG, what drives us is our purpose. Our passion to create products that protect and beautify what matters most to you. Products that enable you to make a home that's distinctively yours. To show off your personality. To make lasting memories like this. And to rest a little easier. At PPG, our family of researchers, chemists, and professionals in more than 70 countries around the world have one purpose. We protect and beautify the world.
That's great stuff. So again, today what we're going to be talking about, our little world, our little slice of pie. We're going to be talking about architectural coatings for metal applications. And
Oh, looks like we are having some technical difficulties. Might take us just a second. Give us a few moments, everyone. So sorry about this.
is our Envirocron 03, our Envirocron 04, and our latest edition is Coreflon Platinum Powder. So the great thing about this is you can go liquid or powder and get the same type of performance across both lines. And the reason that's important today, in today's world, and when I say world, it's getting smaller. So when you're having projects that are coated not only here in the US, but maybe Asia or maybe Europe, you can still get the same type of system and the same coating and a powder system in the US as you would in Europe or Asia. And then across our coil side, so AMA does not recognize the steel piece, ferrous metal, it's only aluminum. But again, you have our Duranar, which is the same resin backbone in our 2605, our Durastar SMP, which is 2604 type performance. And then we go to our Duraform. So across our liquid line, we have the AMA standards all covered with that. And then when you get into touch-up and or remodel applications, we have our Coreflon ADS. And what that'll do for the architect, for the building owners, if you have an existing building and then you do an addition, the addition is going to be probably all 2605 material on the outside, but then you have your existing building. You could go back, apply our Coreflon ADS on the existing building, not only have them look the same, but also be able to go back in 10 or 15, 20 years and they look the same. Where if you used a conventional coating next to a factory applied 2605 powder or liquid, you would start to see a change in that depending on where you are in the country in 2 to 5 years. And another resource I want to tell you about is ppgmetalcoatings.com. Our data sheets are on there. You can certainly take a look at some of our white papers, literature, case studies. You can see some of our certified applicators. But if you're looking for an applicator, if you have any questions, you can certainly give me a call, give me an email, ring us up. We'll certainly answer your questions. Or you could just put something in that email and it actually does come to me, although I rarely look at it. Dan handles those and Dave Harmon. So, but please send us, reach out. We'll help you. And here's a list of our certified applicators. And again, this list is on our website. And we're going to talk a little bit about Duranar coil and extrusion. The product is the same name across both applications. It's 70% PVDF.
Hey,
And
Gary, I'm just going to jump in. Your screen has stopped sharing. When you get a moment, just go ahead and reshare that.
Screen has stopped sharing. How's that? Are we sharing now?
Yes, we are. Thank you so much.
Wow, technical difficulties, and we're 8 minutes in. No, 14. We better get going. Okay, so extrusion coil, right? Duranar. Again, it's been around since 1967. This is where you're going to get your long-term performance. It's the gold star of factory applied coatings. And then we go to our product, our Coreflon Platinum Powder. So the powder coating is used on extrusions. There's not really powder lines out there today or coil lines that are powder, but there are applications that we do use powder actually on some factory applied coil. And we'll get into that a little bit later. So Coreflon Platinum, we've had this product out for about 3 years now. It's actually been on the fence for over 10, and it's trusted and true performance. We've been able to knock the sheen down. So the neat thing about the powder application is you can go from a matte finish all the way up to a gloss, and we're going to talk a little bit more about that later. But one of the biggest things with this product is it's a one coat application. So you can do one coat, and it's a great application for seacoast, right? When you get into those situations, one coat powders have been troublesome over the years. but this product was designed to be a one-coat application and go over aluminum for seacoast applications. So you can see our old product, Chloroform Platinum. Now, keep in mind, you're looking at these pictures and it's like, oh my God, what's happened? Well, these are untreated panels. So this is a down dirty, very aggressive test, right? To see where we are, see what kind of corrosion properties, resistance we're going to have with the material. And the Chloroform Platinum Black, this is 500 hours, but actually we have well over 1,000 and still little to no creep on a non-pre-treated piece of aluminum. I can't stress that enough. So it's very exciting stuff. And to finish it off, we talked a little bit about air dry. This is our Corflon ADS material. These 3 buildings are actually outside of Washington, D.C. in Arlington, Virginia. They were built in 1970, 3 years after 1967 when Duranar was first came out. But anyway, if you go to look at those buildings today, these buildings, the first one that we're looking at there, the other 2 are actually being painted in this photograph, was painted in 2001. The bottom column covers on the bottom were factory applied Duranar. You go to that building today, I was just there right before Christmas. You go to that building today, beaver brown is the color. You can't tell the difference in the 2 materials. So it's great. Typically, you can get a 15-year warranty. It's great for touch-up, and we're going to talk about that today. And then we have some ADS primers to go back and repaint this building here. You see the white. The white's the primer. The red is the finish coat on that. But that building was actually a dark bronze. So, and this one is actually right outside of Crystal City, next to National Airport. So we're going to go ahead and begin the presentation today. It's AIA approved. And we talked a little bit about learning objectives, architectural coatings, right? Liquid powder, the different applications. And we're going to move forward. First thing we're going to talk about today is going to be performance. So we'll jump into that. So we talked about AMA standards. So AMA was Architectural Manufacturers Association. It actually merged with the Insulating Glass Manufacturers Alliance and became FGIA, Fenestration and Glazing Industry Alliance. So what does that mean? Well, AMA standards have been around for a long time, and they're still going to be around, but what you're going to see is FGIA in front of the AMA standard. So I eventually think that it's probably going to be FGIA at one point, and they'll drop the AMA, but it might take a little while. Like for those of you who remember, like John Cougar, right? Then it went to John Cougar Mellencamp, and now who's John Cougar, right? Well, I don't know what happened to AMA. It's FGIA. 10 years from now, maybe. One thing that has changed over the last couple of years is with the standard testing. It used to be a B117 for the salt spray resistance. All 3 standards have gone to the G85 Annex 5, and you can see the difference here: 1,000 hours for 2603, 1,500 hours for 2604, and 2,000 hours for 2605. So that's for the corrosion resistance. But when you talk about color and stability and things, and this is what's really important to understand with the AMA standards, is when you go to 2605, we talk about color shift, right? We're going to talk about how far that color is going to move in 10 years and 5 years and 1 year. We measure that by delta units. And so to pass 2605, you need to be under less than 5 delta units in 10 years. Excuse me, facing south in South Florida. And we're going to talk about that a little bit more. But you can see the difference, 5 delta units. Now we're talking 10 years facing south, right? That gives you the most amount of light during the year. The gloss retention is 50%, and the film's going to erode less than 10%. There's a big cat on the floor over here. So, and then you can see 2604, you got 5 delta units, but it's 5 years, right? And you can actually, the gloss retention is only 30%, but you're still in that 5 delta unit. You can't have more than 10% erosion on the film. 2603, which is typically a residential product, You have slight fade, so there's no delta unit there, slight chalk. There's no real reading there. Gloss retention's it's not even applicable, or film erosion. So you see this a lot on residential, but we also see this on interior in our applications today. So it's very important to understand 2605 standards, or AMA FGIA standards. So again, this is basically going back into that good, better, and best. Something that's important to realize, though, is when you look across these, typically you'll see a fluoropolymer in a 2605. That's the fluoropolymer resin. In a 2604, you'll typically see some sort of ultra durable polyester, maybe some sort of high, maybe less than 100% fluoropolymer, maybe a blend of some sort. And then once you get into the 2603, you'll see a urethane or a durable polyester to meet those performance standards. And what that is that's the backbone of the coating system. And it doesn't matter if it's powder or liquid, the resin is still the backbone of the system. So when we talked about facing south and South Florida, it's actually, I think the latitude is right under West Palm Beach or south. This one's actually in Fort Lauderdale, Sunrise. And you can see the panels are out there and they're tested and they're measured. And part of that panel is actually covered. So it's not exposed. And then you go back and read the panel over the years of performance. And then here, we certainly at PPG, we do testing in Daytona, right there at the Cape, but we also do the G85 accelerated testing. And again, here's some of that testing equipment. And then you do, corrosion protection on different applications. Check your primer. So as we talked about before, the 2603 material, and you'll see, again, the resin is part of, is a big component of the performance. So 2603 products, typically you'll see a urethane or a durable polyester as the backbone. And these products are probably on your garage door and your gutters at your house, right? The residential products, they actually will start to fade and chalk. Mine took about 3 years in the great state of Florida, and it's chalky. And you wash it, it still looks good. But the important thing about that is if I want to go back and repaint it, I can go to the PPG paint store right up the street and see Ed over there, and he'll hook me up with a gallon of PPG paint, and I can paint that garage door and not have adhesion problems because it's already started to chalk a little bit, and it's easy for somebody to go back and repaint once the resin starts to break down for a homeowner. But we also use 2603 products on inside of high-rise monumental buildings, and it works great because especially today with the low E glass, you don't have that UV coming in. They're typically a little harder finish. They're one coat applications, so they cost less, and you don't need that same type of performance. So it could be classified as maybe an EV product, right? Value engineer it out, but I actually have a lot of consultants, architects, and applicators that prefer the 2603 for interior applications, again, because it is a little harder. So just to give you an idea of concept, so before, extrusions were a one piece. So there was no way that you were going to paint this one piece of extrusion, meaning that the inside and the outside, it's one piece, and the glass goes in between. So with the invention of two-part extrusions, now you can take and paint the inside piece right in a 2603 product or even a different color, which was impossible to do. I don't want to say impossible, but you would have to do that application, tape it off, and then paint it again. If you do that, that's more time, more money. So everything used to be 2605. Typically, if it was a 2605 product, the higher standard, you'd have Duranar on the inside or the outside on both of them, right? But with the two-piece extrusion, now we can do two different products. And then we have our ultra durable polyester, which is a 2604. Typically, that's the resin backbone behind it. You'll see, certainly it needs to pass the 5-year South Florida exposure. You get a little bit better corrosion protection, UV protection. You'll see this also on this picture here. This is storefronts, and typically, I don't want to say exactly everything you like to say, but typically it's under 4 stories, right? Under 4 stories or less, you can use a 2604 product. It's not exposed to all the sunlight. It's usually not the sides, the wall. It's not the roof, and it offers pretty good performance like this picture here, a strip center. But it's also can be used on the interior, on interior applications. And when you use that on an interior application, typically the manufacturer will give you up to a 20-year warranty on that product. So what that means is you could have a long-term warranty on the exterior, but then you can also have the same long-term warranty on the interior. When you go to a 2603 material, your warranty on the inside may not be as long as the outside. But again, you may not need that. It depends on the owner, the architect, and the consultant and the designer. Then you get into 2605. So 2605 materials are typically fluoropolymer resin backbones, and you'll see warranties up to 20 years on the coil side. You can see warranties to 30 years, even longer on that application. But typically the extrusion side is 10 to 20 years. And something when I talk about warranties, it's important to understand as a specifier or a designer, or even as a building owner or as a glazer fabricator, is your warranty comes from not the manufacturer of the coating. In this particular instance, if you do go down to like PPG paint store and buy a gallon of paint for your bathroom and you get a lifetime warranty, that is certainly from PPG. But in these applications, you're going to get the warranty from the applicator. The manufacturer backs the applicator. The applicator does all the prep, which is so important, right? Does the application, make sure the color comes out, and also packs the material, ships the material, and is responsible for a lot, for most of everything that happens with that piece of extrusion and or coil. So with that being said, your warranty comes from the applicator. So you need to talk to the applicator and make sure that you understand, and everybody understands, what the warranty requirements are and what warranties are going to be given at the end of the day. It's important to realize that. But as you know, real quick, you can see this is a monumental building. This is in New York City. This is Hudson Yards, and it's a curtain wall. This one actually is a powder coating, and it's long-term warranty. You don't have to go back and repaint that. Who wants to repaint that in New York City? I have a story about that though, because we do that. We just did a big building with ADS in New York City. So, and then we're going to, a little bit about fluoropolymers. When we talked about the chemistry, we talk a little bit about PVDF and FEVE. So those are fluoropolymer resins. The PVDF has been around for a long time. That's what's used in our liquid coatings. And then we have our thermoset, which is FEVE fluoropolymer that we use actually in our powder coat and can be used in liquid coatings. They offer, you talk to different manufacturers, they're going to say theirs outperforms one over the other in different situations. But at the end of the day, when you use a fluoropolymer resin as the backbone of your coating system, typically if it's formulated right, you're going to have something that performs well. So as an architect or as an owner, again, a fabricator, and you talk about all these names that are out there, I throw out Durnar, Coreflon. The important thing is when you look at the data sheet, you understand the chemistry of it, right? What is this? This is a durable polyester, or this is a polyester resin, and we're going to give you a 50-year warranty. At that point, something should say, hey, that doesn't really sound right. Really? You might get a 50-year warranty, but you're probably not going to get the performance that you're looking for at the end of the day. And this is going to show you real quick. So these are test panels. This is a 2603 product. This is 5 years South Florida exposure. This is really exciting. So you look across the top of those panels, that's what's shielded. It's not covered. And then you'll see the windshield wipe, right, going down the side. We don't put windshield wipe in our paint. So sometimes people say, hey, you got some peel on your paint. Well, we don't do that. That wipe is actually for the test to check chalk. So you can see that that's been wiped off and where it is. So this really shows you the type of performance you're going to get out of a 2603 product, South Florida exposure. And then here we go. This is a 2604. This is 10 years exposure. So you can see the performance starts to get a little bit better, even though this has been exposed longer. This is 10 years. And you can see that across all those colors, the colors are true. You wipe the chalk off according to the ASTM test for checking chalk, and these panels pass. There's nothing like real world experience. And so when I talked about resin earlier, and everyone's like, good God, Gary, we're going to sleep here. But this is important, right? Look at Kynar. Kynar, that backbone that we talked about, look how it's performing. And then you look at a silicone polyester, an acrylic, a urethane, a polyester. Initially, if you look at the top of those panels going across and you threw them on the table, nobody knows what they are unless you actually put the material on, unless you actually go through and send it over to like Allison Park and have it analyzed. They're all going to look the same initially, but it's that long-term durability. It's where you're going to get your performance. That's why we talk about resins. And so here's 40-year-old panels, 40-year-old panels. Now remember, I'm a 2605 said 10 years exposure. Here's 40-year-old panels. And you can see the windshield wipe across there. We checked the chalk. Look at that. That's pretty, it's pretty incredible performance. And these are panels that actually have a clear coat on, 35 years exposure. You know what? I actually have these panels somewhere. Let me grab them right here. Yeah, we actually have the panels here. So it's really cool stuff. It's for real. So you can't even tell those panels have been exposed. So we're going to go into fluoropolymer basics. So we talked about Durnar. We got the license in 1967, but it's been around since 1948. And as you go across this timeline, you probably heard of Kynar. Everyone says, oh, Kynar, like it's a product name. It's actually the resin name. So there's Kynar, and then actually in 1996, the company was split up a little bit. So now you have the Hylar 5000 if you look at 1996. So the resin can be a Hylar 5000 or Kynar 500. But in 1982, you can see where the FEVE, that fluoroethylene vinyl ether from Lumiflon, was introduced. So that resin has not been around as long, but 1982, that's over 40 years, that's tried and true performance. So you'll see manufacturers using PVDF, which is, you know, your Kynar 500 or Hylar 5000 resin, or FEVE fluoropolymer resin as the backbone for 2605 materials. And under magnification, this will show you just a little bit about the different resins. So the sheen for a PVDF is typically around 25 to 30, depends on the application, might be a little lower, but you can hit sheens of 10 to 40. So that's a matte to a real low semi-gloss, if you will. But with the FEV resin, that resin actually wants to be a gloss, but you can matte that down and you can get glosses all the way down to a 5, which is super matte. But then you can get, depending on the pigment load and the color, you can get a sheen up to 85. And just for a point of reference, that shiny new car you're looking at getting because it's 2024 and our Auroras are behind us, unless you get the matte black Mercedes or Land Rover, you're probably going to get a gloss, and the gloss is somewhere over 90. So it gives you a kind of point of reference. Excuse me. And here's some sheens, gives you an idea, 15. Then you go into a 50 up to an 80. And again, this is a great chart. I mean, you put this together and you're on your way. But anyway, this is the makeup of the fluoropolymer resins, PVDF and FEVE. Again, you talk to the manufacturers. Listen, we use them both. We feel confident in the performance of both, the way we make our materials. And it's great. It's great chemistry, long-term durability. So when we talk about proportions and resins, and we're going to talk a little bit about liquid and powder now. We're going into this. And the neat thing about powder and liquid, and we talk about these resins, you're like, Gary, resins, polyester, PVDF, FEVE. So the difference is actually when you look at a powder and a liquid is the solvent, right? You take the solvent out of the liquid and then you would have nothing but powder, right? Well, powder doesn't have the solvent, so you still have the same makeup. And if you have a powder and you have a liquid, you can use the same sort of resin backbone behind it. And this is important because I have architects sometimes say, well, I'm going to use a powder coat. Well, it's like, okay, that's great. Still, what type of performance you're looking for? Because we can have a powder coat that, hey, you saw some of those washers and dryers. If you go into Home Depot, some of those actually might be powder coats. But I guarantee you, if you put that washer, put it on your front porch, decorate it for Christmas, come Halloween the next year, you're going to be disappointed. So the makeup between these two materials are the same except the solvent. Very important to understand. So when we talk, this is a can. This is not a gallon of powder, but this is a gallon of paint. And so you can see you have your resin, your additives, your pigments, but at the bottom you have your solvent. Again, the solvent's in the liquid. But if you go to a box of powder, it's the same things. The only thing that's missing is the solvent. So real quick, I mean, we talked about PVDF, FEV comparison. We talked about the different sheens. The FEV may be a little harder. It may not, depending on the way it's the chemistry of the final product. But you can see the difference in the resins. One thing is FEV is super clear, where the PVDF resin is kind of milky. So getting really bright colors is easy to do with the FEVE resin. We're going to talk a little bit about pigmentation. Pigmentation is what gives you the color, right? As you can see there, those powders, those are pigments. There's inorganic, which are super durable. They don't want to fade. And then you have organic, which you can get those really bright colors. Safety red, safety yellow, that super hot pink. And typically they'll require some sort of clear coat. But it's important to understand how the product is made, the color you're looking for, and what type of performance you can expect from that color. It was interesting. I was working on something a long time ago. It was this auto parts place, and they have maybe signature color red, and it turned pink. And they weren't too pleased about that after just a few years. And once they started to understand what was going on with the pigments, and we talked about it, came up with a system, they no longer have a color that turns pink on them. But initially they thought they were getting something because, oh, it's a powder coat and it's red, and oh, this is going to last forever because we put powder coat on our rims, and hell, we drive on that, or heck. So it doesn't mean long-term performance. There's different things that come into play, but pigment, along with the resin, it's a whole system. It's what makes up the product, the end product. And the reason I say this is because if you take a look at this cross here, those colors are pretty similar going right across, right? But one's made with organic pigments, which are super durable, and one was made with a bunch of pigments that were actually inorganic, but you could come up with the same color. And you look at that and you talk about chemistry, and you put those 4 panels across someone's desk and you're going to approve it, you have no idea what you're getting behind what's going to happen in the next 5 years, right? So the way you formulate a color. So as you're picking out colors, as you're going through it, it's always good to understand, hey, what are we doing with this color? Is this color stable? Or something our team says is, listen, we can do that. We can give you that color, but you know what you're going to take off the back end. And some people, some owners are like, I don't care. I want that color. And it's like, okay, we're all in. Last thing we want, though, is somebody said, how come nobody told me this was going to happen in 3 years? Boy, we're moving fast now. We got metallic and mica pigments. So sometimes we talk about clear coats. Our XL products have clear. Sometimes clears are used to add more durability on top of those organic pigments to help stabilize the color. But some of the colors that we make actually, and manufacturers will make, will actually have pieces of metal flake. And those metal flakes, we need to protect them. So we'll put a clear coat on there to make sure that they hold their color fastness and they do not corrode long term. Again, we're talking about some of these products and we're talking about warranties and different things. The American Airlines arena at JFK was painted in 1970. They ripped that off and they're rebuilding it right now, right? But they tore that building down. It was dated, but the color, the painted metal did not need to be painted, which is pretty impressive. So, but again, that was a solid color. It didn't need the clear coat. So we'll use the clear coat to help protect those pieces of metal flake. Now, mica, it's actually an ore. It's pearlescent. You can get similar type appearances. You can get something that kind of glitters. Actually, mica is used in makeup. So you can get that glitter and you don't really need the clear coat, huh? But anyway, it's a more economical choice. It's typically, depending on the product, a 1 or 2 coat. It doesn't require clear for long-term performance. And there's so many different pigments out there, right? There's polychromatic pigments, which is really exciting. That's when you look at it one day, it's blue, next day or next angle, it's red. You see that in cars. It's actually started on the automotive side, but there's actually a lot of buildings for those architects out there that want to be brave and go outside and not pick silversmith. We can do it. We have a couple color stylists and we know how to make that work. But also you have micas and you have clear coats. Again, with the powder coats, you have the sparkle. You could get the salt and pepper look. So these are effects that pigments add to the coating. You got texture. You can also do some semi-transparent. So that's done certainly with some clear coats. And again, we talk about that polychromatic pigment and how it changes depending on the angle, and you're using silicon dioxide to try to divert the color to make it travel. It's really interesting. And so some manufacturers can do that in liquid. A lot of them do it in liquid. You see it in automotive. And some manufacturers can do it in powder. So it's exciting stuff. This kind of shows you, this is USF, and you can see it looks gold at the front, but the side of the building actually looks red. So this is what pigments can do. And also pigments can also take like coil coated, like this is coil, and put some sort of wood grain to it, right? With different application techniques. So you can make metal look like wood, which is very exciting. And we're going to talk a little bit about application. It's getting good now. So we talked about coil and we talked about extrusion. And in this picture, if you look, you see those rolls up there. It's like the guy who comes and put the gutters on your house. He's got that roll. If you get the seamless, you don't want to go buy those. Well, you might. I don't want to say, but anyway, the seamless gutter's nice because it's seamless and it won't leak, right? But anyway, he's got that little roll behind his car and he forms it, but it's already painted, so it's formed. Makes your 4-inch gutter or your 6-inch gutter, and it's formed and painted. So those are coil products, which is really interesting because how it's coated. We're going to learn a little bit about that. And then you have your extrusion or sheet aluminum or plate aluminum, right? So that's you're in the office today, you're looking out at the nice sunny day here in Springdale like I am, you can look out those windows and you see those extrusions around the windows, those pieces of metal, the door frames, those are extrusions. So you see it storefronts, window frames. I think everybody gets the idea. But there's different application techniques. So we're here. So this is extrusions, right? You see those long pieces, and this is a vertical line. So those pieces actually on the right are being lifted up. On the right, if you can kind of see that, they're being lifted up into the line. But those pieces are going to go through. They're going to be cleaned, pre-treated, dried, primed if the system needs a primer, dried, painted, dried, and then it's going to recover. And at the end of this line, you're going to be able to take those sticks and wrap them up and ship them. But this is a vertical line, and typically vertical lines have a different application technique. So these are put on typically with a disc. So this is those same extrusions, and you'll see the applicator going down. Now this is automated, but that disc is spinning super fast, releasing the paint and coating. That disc is going up and down, and as those extrusions move through, they're turning and being twisted, and all sides are getting painted. So it's important to understand that this is a vertical line. This is a disc application. So when you start talking about some of these colors and different applications, I just want this color, and we're just going to paint these extrusions. We're going to paint all this coil, and we're going to do it in powder. We're going to do it liquid. We're going to do it in Europe. We're going to do it in Florida. It's like when you do all that, you really need to understand that although you're asking for a color and there's a color number, you're going to have to modify. The manufacturer should and work with their applicator to modify that color to ensure that it comes out, because the color, the same material going across these different applications, is not going to look like the same color at the end of the day. I got to shut that off. I can't get milk because I'm in Springdale. I'm not at home. So anyway. So here you go. So here's a horizontal line. So see the line is horizontal, and this application might, I can't tell what's going on. It's a puff of smoke. It's a powder gun, right? This is a powder application. So this is plate. This is a horizontal line. See, the horizontal line can actually put some really heavy, big pieces on there. This is a manual application. So some horizontal lines are automated, some are both. So again, this is a powder application. And this kind of gives you an idea of the different lines that are out there and the different techniques. And so this is a coil. This is a coil application here. So there's a pickup roller picking up material. It's putting on another roller, and it's actually put it in on the piece of, and I want to say aluminum because we talk a lot about aluminum, but actually it could be galvanized galvalume. It's typically ferrous metal. You'll see a lot of ferrous metal coil applications. So when you look at this application, on the far left-hand side, you see those big rolls over there, and they're being unwound, and they go through that accumulator, which actually can buy time on the line, right? If you laid out that flat sheet of metal and ran it through the line, you don't ever want to run out of material in your line. You don't ever want to rethread that. So you can take with those accumulators and raise them and lower them and make it more distance to travel. It's kind of like Disney World, right? When you go there at midnight, they don't need all those lines. But if you're there at 8 o'clock in the morning on the 4th of July, you got more lines to go through, zigzagging back and forth just to get to the same place. So anyway, it goes through there. It's cleaned, it's primed, it's dried, it's painted. And you see it's at the end, they wrap that right back up. So it's already cured. And they wrap that up, and then it's ready to be fabricated. Very interesting stuff. It's really cool. But these are different applications. And this is why we're here today, is because we're talking about different applications. We're talking about different products. We're talking about different colors. We're talking about so much. But why is this important? Because if you pick out that nice silvery color, Arcadia silver is a real popular one, right? And you put it down and we do a spray application, that first picture at the top says, they both say liquid or blue, right? And those flakes are going every which way like they're blowing in the wind. Well, they kind of are, right? They're during the application. It could be automated, but it could be hand spray. But anyway, you see those flakes, somebody's spraying that at different angles. The application is not consistent. So those flakes are going to lay in there all sorts of different ways. It's like when you were decorating those Christmas cookies just 2 or 3 weeks ago. When you were throwing all those sprinkles on, they laid all sorts of different ways. The next picture, though, this is important, is the coil application. So you look, they're all uniform. Those little squares, they're pretending those are mica flakes or metallic flakes. Super smooth, very uniform. You turn that panel different ways, it's going to be very consistent. The colors are very consistent. It's a very consistent application. We just saw that. It's all automated. So if you get the same color, you could have actually, between the two applications, you could have something that looks a little different. And then the last application that you have is a powder application. Now, you see the powder's green because powder is green. It's great for the environment. But you can see the flakes are a little bit orientated. They're in between, right? They're a little bit more consistent in the spray version, but not as consistent as the coil version. The powder is a little bit more suspended. So the reason of that is typically the powder is bonded when you have any kind of mica metallic. So it sticks to the powder. So everything's more consistent. Also, your powder film, do you see that? 3 mils. We make it look like 3 miles here. But with that being in there more consistently, your application is more consistent with your micas and metallics. The reason you bond it, if you didn't bond it, it'd be like eating those cornflakes back in the day, back when life was good at 9 years old. But if you remember that bag of cornflakes at the bottom, that's where all the sugar was. My mom loved that when my brother got into that stuff. He was a wild animal. Get him all that sugar. It was going to be a good day. But anyway, you can see the different applications. You can see the different colors. And you can see how everything changes. So it's important to understand the application. It's important to understand the color. And it's important to understand the technology that's you're going to utilize. So we talk about different applications. So the AMA standard is 2 delta units. So in theory, you can't be beyond 2 delta units of the sign standard. And the sign standard is very important, right? It's something that's agreed by everybody. It's not the standard of Arcadia silver from 2009 and a sample that somebody else has of Arcadia silver manufactured in 2022, right? There's going to be a difference. So you don't know where those panels have been, what's going to be consistent. So it's important to get the line sample that, hey, this is what is going to be approved. All manufacturers are making colors. Mistakes happen. There's different variations. That can happen. That's why you start picking a color, then you have your line. Have a line application, and then you can look at the color, and then we can approve that color. And from there on, 2 delta units is as far as that color can ship. So it takes all the guesswork out, and whose color is right. So that's very important. So the difference between liquid and powder coatings. We got 6 minutes. We're going another 20, though. It's all good. This is good stuff. I hope everyone's having a good time. So we're going to get into liquid. So we talked about a 2-coat system. You have your substrate, then you have your pre-treatment. This is pretty standard. Some need a primer, some don't. Primer coat's about 0.2 mils, and your finish coat is 1.8. So at the end of the day, your typical probably PVDF system is probably on a liquid side is around 1 to 1.2 mils, right? Then you jump into a 3-coat system, which is, you still have the primer. The barrier coat's typically not used today. Sometimes it's required. Some specs, actually some military specs require the barrier coat. Some owners want the barrier coat. More paint's good, right? Because I got to buy milk this afternoon. But anyway, you get into the top coat, it's about 1 mil, but there's your clear coat. It's about a half a mil, 1.5. So that's a 3-coat system, 3 or 4-coat system, but you can see the difference. But again, even if you're a liquid system here, you're talking at the end of the day, you have a primer, skip the barrier, and then you have the finish coat. You're at what, 1.6 mils? 1.6 mils. That piece of paper you're writing on, taking all your notes on, anyway, it's about a mil. So it gives you a perspective. But this is important because we're talking about liquid, we're talking about 3-coat, 2-coat systems. But then you go into powder coats, and then you get your powder coat, and that's 3 mils, no primer. If you do have a primer, you're going to add maybe another half mil to a mil. But the top coat's typically 3, right? It's typically 3 to 5 at the end of the day, right? So you can see the difference in thickness on these materials. And these are all things that are very important to understand. The reason it's important to understand is because when you start adding the thickness of the material, solid colors is actually pretty consistent. I can get a bone white in a powder and a liquid, throw it out there in 6 different technologies. I can even go down and see it again at that PPG paint store. I could have all these bone whites look the same. It's all pretty great. But when you get into something like Silver Star Gallica Silver, right? Well, you're going to start seeing differences between powder and liquid. So it's always good to understand what you're looking for between powder and liquid and getting into those micas and metallics. We find it's best to get the mica and the metallic. You can't get that same load of metallic in a liquid. Although our powder coats today, you get into the silvers and the metallics, are head and shoulders of where they were 10 years ago. It's actually fantastic. But it's important to pick out, to understand if you're picking out a color, going down this design phase and knowing that it's going to be sourced from many different applicators using many different technologies, that you may want to try to keep your colors not very exotic. And I mean this both in terms of powder and liquid. So we talk about this silver flake, and you punch a bunch of silver flake in there, because if you look at that 1 mil and say each one of those is a piece of mica, there's 5 in 1 mil. So they're pretty close to the top. You take those 5 pieces of mica, though, and put them in 3 mils, what's going to happen? You're not going to have the same sparkle in there. So it's almost going to be impossible to get that same type of really glittery sparkle like your Christmas tree consistent in the powder coat next to a liquid, right? But keep in mind, when we talk about these pigments, if you're going down the path of a powder coat, because a powder coat, we haven't talked about that, can have multiple colors in there, so you can get a salt and pepper look. You cannot do that with a liquid. I don't want to say you can't do that. You cannot do that with a liquid and have it be cost effective. It's just not going to work. So there's a little bit difference between micas or powder and liquid. But the important thing is to understand the colors you're picking out, what products you're going to use, where it's going to be sourced, and make sure you can get the colors consistent across all platforms. So when you ask the manufacturer, well, how come I can't get this color in liquid? Or how come I can't get this color in powder? There's a reason. So going into this, it's always important to consult the manufacturer and see what they say to keep everything more consistent and get your colors and your technologies aligned. And more importantly, your expectations and your customers' expectations. So we just talked about this, the liquid and powder, the 5 pieces in there, right? There's only so much you can put into a powder. If you put a bunch into a liquid, it all sits on top. And we talked about appearances somewhat. Again, solid colors are pretty consistent along all technologies and applications. This says liquid can be smoother than powder. It can. But I will tell you, we've seen some applications where the liquid looks like, hey, is this a powder coat? That's a conversation for another day. But actually, powder actually has become very smooth. We have so many powder samples. I lay them out on the table at shows, and people can't tell the difference. They can't tell the difference between powder and liquid. It's pretty phenomenal. And the mica and the metallics, especially in the powders, have come a long way. So again, we talked about a little bit about the silver and the powder, but when you talk about powder and you talk about design and what you can do with powder, you can get some sort of texture in a liquid, but not like you can in a powder. So with powder, I mean, we can do stone look, you can do speckles, velvet. There's you can actually do anodize, you can do micas, micas and metallics with texture and a high sheen. It's the design capabilities are actually endless with powder. It's very exciting stuff. But keep in mind, so you pick something like that granite spackle there, which is, yeah, that looks good. But if you need to touch that up, I would recommend that you go to the applicator, the fabricator, and say, how are we going to touch this up? And see what sort of solutions they have. Because you want to figure out touch up before you need touch up, right? You want to make sure you got those answers before, you got 40 stories up and everyone's shaking their head, and you got, Doris from the art store trying to touch up, 70% PVDF coatings. So, and, it's funny, it's powder versus liquid, because that's all I hear is it's powder. Are you powder? Are you powder versus liquid? I will tell you, I've been on several projects, too many projects, but it's really exciting. But everyone says that they're supplying it, and everyone says it's a liquid job or it's a powder job. I will tell you, I work with the projects my team works on, it's powder and liquid. It's like whatever you want to do. We're using both of them on the same project. And when I've actually had architects say, oh, there's no liquid on my job, or there's no powder on the job. And we're sitting there going, oh, there is. Somebody has sourced something from somewhere else, and so it's powder and liquid. It's important to understand, the capabilities of both. There's no like liquid's better than powder or powder is better than liquid. It just depends on where you're sourcing. You're sourcing from Europe. You know what? Powder is going to be a lot easier to get. It's going to be you can get that put on, and then you can have powder put on in the United States, right? And or Mexico or South America, right? So you could just you just want to understand what you're doing when you're specifying a job, what to expect, and where it can go. So, but again, powder, you got that one coat capability, and you can do a stone look, which is fantastic. And then here's the manufacturing process. I mean, you see you got bases, tints, but again, you still in this bucket here, you got resin, pigment, binder, right? All sorts of other additives in there in the solvent. But when you get into a powder coating, right, it's powder. There's no liquid in there. We use it all the time. It's been used. It's used for so many different substrates, but it's really becoming popular in our industry on buildings. So the difference is, right, we talked about that the solvent being the only thing missing out of a powder. And you're like, well, how do you mix that up? And how does that happen? Well, it's actually really neat. So you take all those ingredients that are dry and you don't add any solvent, and you go ahead and you extrude them, right? You heat them up, you extrude them, you make them into almost like a big potato chip, and it's cooled down, and then you break all those chips up, and then they're ground up, and then next thing you know, you have powder. You got a box of powder. And this kind of shows you how it goes through, right? At the hopper on the left-hand side, all those ingredients are put in, you feed it through, right? You got your extruder. You see that belt down there? That's the big potato chip thing. It's going to lay it out there. It's moving it down. So it's being extruded. It's being cooled. And by the time it gets to the end, it starts getting chopped up. Next thing you know, you got a bunch of little fines, the powder goes to the grinder, and it goes to the cyclone. And next thing you know, it's in the box. And then really cool thing, and this is really good about powder, is not only you're not using solvent, but you're collecting all that stuff, all that powder back in, and you can recycle that and use it again. So there's very little waste. So You talk about sustainability with powder. It's no VOC, right? The overspray can actually be reclaimed. So all the spray, if the applicator is using the proper boost, everything that you spray on there with the powder that misses because it's actually the piece is grounded. It's electrostatic, so most of the powder gets on the piece, right? It's very efficient, but some of it misses. So you can actually scoop that powder up, put it back in to hopper for application later. And also, you don't have to clean up your equipment, right? So when you talk about a liquid system and you start changing colors, you're actually going to need solvent. So you're going to need solvent to clean that up. So powder does have the sustainability advantage. And this just shows you a little bit about, the U.S. is mostly liquid, but that's switching. Europe is mostly powder. Asia's kind of flipping around, but the world is going to powder. And everyone says, well, powder started over in Europe, and why did powder start in Europe? Well, powder was easy to make an ultra durable polyester and powder, a lot easier than it was to make a fluoropolymer powder. It was less expensive. But when we talk about South Florida testing, and we talk about AMA standards, and you look at the further away from you get the equator. So I don't know if you ever go to vacation down in like Key West, right? You'll notice you'll burn up a lot faster in Key West than you will even in Orlando, and certainly faster than here in the great city of Springdale. So the further you get away from that equator, right, the sun's not so intense. And Europe is also, I'm getting the look. I got to go. Anyway, Europe's at a higher latitude, and so that's where ultra durable polyesters have come from. So again, here's a couple projects that we've done over time that have been done in powder. Everybody's done. And this is really neat. This is a coil application with the powder put on top, so you can get metal that looks like shingles. So I'm trying to get through because I know everybody's got to go. We talked about liquid powder coatings, one coat capability, Seacoast performance with our powders, liquids proven Seacoast performance. Last thing I want to talk about is touch up. You look at this picture, this was touched up. It wasn't touched up like that. I guarantee you, just like we saw those other pictures before with different pigments, if you have something that's going to last for 50 years and you touch up with a can of paint from your local hardware store, it's not going to perform the same, and you're going to get this sort of look. So it's important to touch up with the same type of chemistry. I'm coming back over. Did she leave? I'm going to stop sharing. We're going to take some questions. It's 2:08.
If there are any questions, feel free to submit them into that chat box, or you can submit them in the Q&A section.
Okay, I'd like to thank everybody for their time. I'm sorry we went over a little bit. There was actually some good stuff in there, but please, and if you have any questions, please reach out. We'll be more than happy to help and figure it out. It's good stuff. It's exciting. Happy 2024, everybody.
Same to you, Gary. Thank you so much for being our speaker today. Thank you for joining us on our very first MetalCon Live of 2024. We are so excited for what the future holds. We're so excited to see PPG in the future, hopefully at MetalCon this year. We shall see. And thank you everyone here for staying with us, for watching this, and we look forward to seeing you all on future programming. Thanks, everyone. Have a great new year. And if you have any further questions, do not hesitate to reach out to me, Kaylin@metalcon.com, or to Gary if you have specific questions about this exact presentation. Either of us will be happy to help you in whatever way we can. Thanks, everyone. We'll see you soon. Bye-bye.
Thank you. Bye.